The past decade has been nothing short of a revolution in how we see the universe. With each new launch, each new lens pointed toward the heavens, humanity has pulled back the veil on mysteries once thought untouchable. And at the center of this golden age of discovery stands the James Webb Space Telescope, a machine so powerful it can peer back in time itself, capturing the faint whispers of galaxies born billions of years ago. It is our eye in the dark, our sentinel against the unknown. But Webb's mission has never been just about beauty or curiosity. It's about vigilance. Twice before, interstellar wanderers have entered our solar system, first the enigmatic Oumuamua, whose cigar-like body sparked whispers of alien engineering, and then Borisov, a comet blazing with unfamiliar ice from another star system. Both came and went, indifferent to our fragile planet. But the pattern was set. We are not alone in receiving visitors from the stars. Now, Webb has joined that story, scanning the deep void with impossible precision. In its silence, it waits. Until one night, a faint anomaly shimmered into view. Not drifting lazily like a comet, but tearing across space with breathtaking speed. And then it saw something moving fast. Too fast. When James Webb locked onto the anomaly, the data arriving on Earth was unlike anything scientists expected. It wasn't the faint signature of a passing comet, nor the elongated silhouette that once baffled them with Oumuamua. Instead, it was sharper, brighter, pulsing with a strange irregularity, as if reflecting sunlight in ways no natural object should. Calculations showed it was moving at breakneck speed, faster than most comets ever recorded, a clear sign it was not born in our solar system. This was another interstellar wanderer, later named 3I TLAs, the third of its kind ever seen. Yet, unlike its predecessors, this one wasn't on a harmless detour. Its trajectory pointed straight toward the inner solar system, brushing dangerously close to Earth's orbital path. The comparisons were immediate. Oumuamua had puzzled astronomers with its cigar-like shape and bizarre acceleration, while Borisov had been more familiar, a comet dragging a tail of alien ices. But 3I ATLAS was different. Its orbit didn't line up with a casual flyby. Instead, every new calculation pulled it closer, narrowing the margin of safety. Scientists around the globe began running simulations, each one flashing red with probabilities no one wanted to see. Was this the first interstellar object to make Earth its destination? Time became the enemy. Supercomputers crunched numbers. Day and night, desperate to refine the trajectory, while telescopes worldwide scrambled to confirm Webb's findings. Each observation confirmed the same unnerving truth. This object was not veering off course, it was coming straight in. The tension mounted, scientists whispering of a potential impact window no one dared announce publicly. And then came the twist. Webb's high-resolution scans revealed something even stranger than its trajectory, something that defied expectations. Because the deeper they looked, the stranger it became. The moment Webb's detection went public, the astronomical community fractured into camps of cautious optimism and hushed alarm. At NASA, mission leads were quick to reassure the press, emphasizing that preliminary models showed a high probability of a safe pass. "We've seen this before," one senior astronomer said, invoking the memory of Borisov. "Odds are it will slip by without incident." But behind closed doors, the tone was different. Some calculations suggested a far narrower missed distance. And those results were quietly circulated among only the most senior officials across the Atlantic. The European Space Agency urged patience, noting that trajectory data is notoriously unstable in early days. Still, whispers leaked that several of their researchers had flagged non-gravitational accelerations, the same mysterious pushes that made Oumuamua such a riddle. Independent astronomers, free from the constraints of official messaging, sounded more unsettled. One compared the light curve to a rotating object with uneven surfaces, or perhaps something reflecting deliberately. That word deliberately set conspiracy forums ablaze. The biggest tension came from what the object actually was. Some called it a comet without a tail, some insisted it resembled an asteroid fractured into shards, while others wondered aloud if its reflective patterns hinted at something engineered. Was it natural, or was it something else entirely? Public trust wavered as statements contradicted each other, and for every calm assurance, a leaked email or a late-night podcast added fuel to the fire. By the third week of observation, no consensus existed, only confusion. To some, it was harmless, to others, potentially catastrophic. And as the world argued over rocks, comets, and alien probes, one truth became undeniable: the mystery was only growing. And that's when the theories exploded. The swirl of speculation came like a storm. To the scientific mainstream, 3I Atlas was most likely just another comet, an icy traveler flung from a distant star system, glowing faintly as solar radiation tore gas from its frozen body. The safest interpretation was also the simplest. It would miss Earth by a wide margin, as so many cosmic wanderers have before. Yet even among those calm voices, unease simmered. A few orbital simulations suggested that a gravitational nudge from Jupiter or even Earth's own pole could alter its path, tightening its course in ways that no one could yet predict. If that happened, the story could shift from harmless visitor to existential threat. Beyond the sober calculations, more radical whispers spread. Some astrophysicists dared to compare 3I Atlas with Oumuamua, the interstellar enigma that sparked debates about alien engineering. This object's strange reflections and erratic speed gave conspiracy theorists fresh ammunition. Could it be a probe, deliberately steered? Was Earth the target, not just an unlucky obstacle? Forums buzzed with talk of cosmic reconnaissance, while mainstream scientists bristled at the idea but couldn't fully dismiss it. The public, caught between reassurance and alarm, asked the question no one wanted to answer: if there's even a 1% chance of impact, what then? Evacuation? Deflection? Or resignation? For now, all anyone could do was wait as the telescopes gathered more light, more numbers, more questions. And when the data came back, it revealed something no one expected. The breakthrough came when Webb's instruments locked onto the object with higher precision, peeling away the uncertainty that had clouded earlier data. What emerged was startling. Instead of a dull, steady reflection like ordinary rock or ice, 3I Atlas shimmered in irregular pulses, as if parts of its surface were metallic, glinting like fragments of a broken mirror. Some readings even suggested the light was bending unnaturally, scattering in patterns no one could quite model. Suddenly, the safe assumptions about a benign comet or asteroid no longer held. This was something different, something bigger. Revised measurements hit like a thunderclap. The object wasn't a few hundred meters across as first believed. It was several kilometers in diameter, rivaling the size of the asteroid that once ended the reign of the dinosaurs. If those numbers were correct, an impact would mean not just regional devastation but a global catastrophe. Worse, the new models showed that even a minor miscalculation in its path could shorten the timeline, moving an impact window from centuries away to mere decades or less. The margin for error shrank with every recalculation. Behind the scenes, the mood shifted from curiosity to crisis. Emergency meetings sprang up in classified briefings, drawing not just astronomers but military strategists and political leaders. If this object was natural, it was a threat of unimaginable scale. If it wasn't, the implications were even more unsettling. Governments quietly began allocating resources to monitor it independently, while military satellites were redirected to track the anomaly. Meanwhile, whispers of the discovery leaked to journalists, and soon social media erupted with grainy charts and speculation that no official statement could suppress. The world was watching, and trust was eroding. The tension climbed as simulations poured in, each one narrowing the safety margin further. No matter how carefully scientists reran the models, the possibility of a near miss or worse lingered, like a shadow. And then, after weeks of frantic work, came a simulation unlike any other, a result so shocking that those who saw it first reportedly sat in silence before daring to speak. Because in that projection, Earth wasn't just close to danger. It was directly in the crosshairs. And then came the simulation that changed everything. If the simulations were wrong and 3I Atlas veered harmlessly past, humanity would still gain a once-in-a-lifetime opportunity. A safe passage would allow telescopes and probes to study the object up close, peeling back the secrets of another star system without ever leaving our own. We could learn how alien comets form, what materials they carry, and whether the building blocks of life might drift between stars like seeds on the wind. In that best-case scenario, 3i Atlas would be remembered not as a threat but as a gift, a rare visitor offering answers to questions older than civilization itself. But the worst-case scenario is far darker. If its path tightened, if gravity pulled it just a little too close, the consequences could rival the Chicxulub impact that wiped out the dinosaurs 66 million years ago. An object of this size striking Earth would unleash unimaginable energy, cities erased in an instant, global climates thrown into chaos, and human history forever split into before and after. That possibility, however slim, is what keeps scientists awake at night. Talk inevitably turned to planetary defense. The DART mission proved we can nudge an asteroid's path, but that was a small rock in our neighborhood, not a colossal interstellar projectile moving at unimaginable speed. Some spoke of nuclear deflection, others of mass drivers or futuristic lasers, but no solution came without staggering risks. And looming over every plan was the chilling reality: humanity has never faced something like this before. For the first time, we're not simply gazing outward in wonder. The universe isn't just letting us look, it's moving toward us. And the question echoing in every lab, every war room, and every late-night conversation is terrifyingly simple. Are we ready? From the moment James Webb's golden mirrors first caught its faint glimmer, 3.1 Atlas has been more than a discovery, it has been a warning. What began as a blip of light grew into a riddle that split the scientific world, a massive interstellar visitor on a trajectory no one can fully explain, shimmering with patterns no one can dismiss.